Hi everyone, welcome to Technology World Hub. My name is Anil. In this series, we are going to discuss the top 100 core Java interview questions and answers, which covers 50 intermediate core Java interview questions and answers and 50 advanced core Java interview questions and answers. In the last series, we discussed about 50 basic core Java interview questions and answers. I highly recommend whoever not attend that series, please watch that series of top 50 basic core Java interview questions and answers on 2025 so that you will get the basic idea or basic knowledge. Then you can continue with this series. So for this series, let's start this. First question. What is the purpose of the assert statement in Java? The assert statement in Java is used to validate assumptions during development and debugging. It checks whether a given expression evaluates to true. If the condition is false, an assertion error is thrown. Assertions are mainly used for debugging and testing purposes to detect logical errors early in the development process. Next question. What is the difference between array list and linked list in Java? Array list. A resizable array based data structure that provides fast random access, that is order of 1, but slower insertions and deletions, which is order of n, due to shifting elements. It is preferred when frequent access operations are needed. Linked list. A doubly linked list implementation that allows efficient insertions and deletions, that is order of 1, but a slower random access, that is order of n. It is more suitable for scenarios with frequent modifications and dynamic resizing. Next question. What is the purpose of the hash code method in Java? The hash code method generates a unique integer value, that is hash code, that represents an object's contents. It is primarily used in hash-based collections like hash map, hash set, and hash table for efficient storage and retrieval. A properly implemented hash code ensures better performance in hashing based operations. Next question. What is the purpose of the toString method in Java? The toString method returns a string representation of an object, typically including its class, name and key attributes. It enhances debugging, logging, and object readability. When an object is printed or concatenated with a string, the toString method is implicitly called. Developers often override it to provide meaningful output. Okay. Next question. What is encapsulation? How encapsulation achieved in Java? Encapsulation in Java is achieved using access modifiers, that is private, protected, public, to restrict direct access to class members. It ensures data hiding and maintains control over how data is accessed and modified. Getters and setters are commonly used to enforce controlled access to private variables. Next question. What are method references in Java? Method references provide a shorthand way to refer to existing methods without executing them immediately. They improve code readability by replacing lambda expressions with direct references to class or instance methods. They are used with functional interfaces and are written as a class : method name. Example: system.out : println instead of x arrow mark system.out.println x. What are annotations? Next question. What are annotations in Java? Annotations in Java are metadata tags used to provide additional information about code elements such as classes, methods, and variables. They start with @ that is @override, @deprecated, and are used for configuration, code documentation, validation, and runtime processing. Annotations enhance code organization and facilitate frameworks like Spring and Hibernate. Next question. What is the bit set class used for in Java? The bit set class represents a sequence of bits that can grow dynamically. It provides efficient bitwise operations such as setting, clearing, flipping, and checking bits. It is used for memory efficient handling of binary data such as flags, filters, and permission settings. Next question. What is a cyclic barrier in Java? A cyclic barrier is a synchronization mechanism that allows multiple threads to wait at a common barrier point until all threads reach it. Once all participating threads arrive, they proceed together. It is useful in parallel programming scenarios where tasks must be synchronized before continuing execution. Next question. What are the types of JDBC statements in Java? JDBC, that is Java Database Connectivity, provides three types of statements for database interaction. First one, statement executes simple SQL queries without parameters. Prepared statement, precompiled SQL statement with placeholders for parameters, improving performance and security. Callable statement, used for executing stored procedures in the database. What is the Java string pool? The Java string pool is a memory optimization technique where the JVM stores string literals in a common pool to avoid redundant allocations. When a new string literal is created, the JVM checks the pool first. If the string exists, it reuse the reference instead of creating a new object. This conserves memory and enhances performance. If you will see in the example, string str is equal to hello. In this case, str will be stored in the stack and hello will be stored in string constant pool, which is inside heap memory. Okay. str will be stored in stack memory. Next question. What is the difference between path and class path? Path specifies the location of system executables like Java and Java-C. Class path specifies the location of Java class files, jars, and resources. Path is used by the operating system while class path is used by the JVM. The path is set via the path environment variable, whereas class path is set using class path or -cp option. Example, set path is equal to, let's say, c:/java/bin, that is path. Set class path is equal to c:/lib/mylib.jar, that is class path. Next question. What is the difference between heap and stack memory? Heap memory. It stores objects and data that need to persist throughout the program, managed by the JVM's garbage collector. Stack memory holds method call, frames, and local variables. It manages method execution and automatically deallocates memory when a method exits. Next question. Can we use string with a switch case statement? Yes, string can be used in a switch case statement from Java 7 onwards. The switch works by computing the hash code of the string and then comparing it. Let's say string fruit is equal to apple, switch fruit, case apple, system.out.println, it's an apple. Break. Case mango, system.out.println, it's a mango. Break. Default, system.out.println, unknown fruit. What are the key points here? Case labels are case sensitive, that is apple not equal to apple. Okay. Uses a string.hash code for comparison internally. Okay, here, one second guys. Yeah. So here exactly it will be, one is all capital letter apple, another might be all small letter apple. Uses a string.hash code for comparison internally. Less efficient than integer based switches due to hashing. Okay. Just think, this apple, APPLE, this string is not equal to small apple. Let's say APPLE in small letters. Okay. Next. What are the different types of class loaders? Java has 3 primary class loaders. Bootstrap class loader loads core Java classes, that is rt.jar. Extension class loader loads classes from the JDK's extensions directory, that is java_home/libs/ext. System class loader, that is application class loader, loads application classes from the class path configurable using -cp or -class path. Next question. What is the difference between fail fast and fail safe iterators? Fail fast iterators immediately throw a concurrent modification exception if a collection is modified while iterating. Fail-safe iterators operate on a cloned copy of the collection, allowing modifications without exceptions. Next question. What is a compile time constant in Java? A compile time constant is a value assigned at the time of compilation and remains unchanged throughout execution. Example, static final int max underscore value is equal to 100. Next question. What is the difference between map and queue in Java? Map stores key value pairs and allows fast retrieval based on keys, that is hash map. Queue stores elements in a specific order, that is FIFO, first in, first out, priority based, etc., designed for processing elements sequentially. Next question. What is the difference between linked hash map and priority queue? Linked hash map maintains insertion order and maps keys to values. Priority queue orders elements based on priority, natural ordering, or a custom comparator. Next question. What is a memory map buffer in Java? A memory mapped buffer allows a file to be directly mapped into memory, improving I/O efficiency by enabling direct access to file contents, useful for handling large files. Next question. What is the difference between notify and notify all? Notify wakes up one waiting thread. Notify all wakes up all waiting threads. Next question. What are the types of exceptions in Java? Checked exceptions, that is I/O exceptions, must be handled at compile time. Unchecked exceptions, for example, null pointer exception, occurs at runtime and does not require explicit handling. Next question. What is out of memory error? Error when JVM runs out of memory, caused by memory leaks, large objects, or infinite loops. Next question. What is the difference between equals to and equals method? Equal to compares references, memory addresses. Equals compare object content, must be overridden in custom classes. Next question. How can you concatenate multiple strings in Java? We can concatenate multiple strings in Java in different ways. First one, plus operator. Simple but creates new objects. Concat function works with string. String builder dot append. Efficient, recommended for multiple concatenations. String dot join. Introduced in Java 8. What are the main differences between array and collection? Array, fixed size, stores elements of the same type. Collection, dynamic size, can store elements of different types, that is array list, hash set, etc. Next question. What is blocking queue in Java? A thread-safe queue that blocks when empty or full. Used in producer-consumer patterns. Example, array blocking queue, linked blocking queue, etc. Next question. What is the difference between process and a thread? Process, independent execution unit with its own memory space. Thread, lightweight unit within a process, sharing memory with other threads. Next question. What are the advantages of multi-threading? Efficient CPU utilization, faster task execution, improved application responsiveness, better handling of I/O operations. Next question. What is content switching? What is context switching? The process of saving a thread state and switching to another. Happens in multi-threading and multitasking. Causes CPU overhead. Next question. What is the difference between array and array list? Array, fixed size, stores primitive types and objects. Array list, dynamic size, stores only objects, provides built-in resizing and utility methods. Next question. What is the purpose of the volatile keyword? Ensures visibility of shared variable updates across threads. Prevents instruction reordering. Used in multi-threading scenarios. Next question. Explain Java NIO. Java NIO, that is new IO, provides faster IO operations using channels and buffers for data transfer. Non-blocking IO for synchronous processing. Selectors for managing multiple channels with a single thread. Next question. Difference between string, string builder and string buffer. String, immutable, slower for modifications. String builder, mutable, fast, not thread safe. String buffer, mutable, thread safe, synchronized. Next question. Difference between runnable and callable. Runnable, no return value, cannot throw checked exceptions. Callable, returns a value, future of t, and can throw checked exceptions. Next question. What is a checked exception in Java? Exceptions checked at compile time must be handled using try catch or throws. Examples: IO exception, SQL exception. Next question. Difference between static and final keywords. Static belongs to the class shared across instances. Final makes variables constant, prevents method overriding and class inheritance. Next question. What is an unchecked exception? Runtime exceptions that do not require handling, that is try catch. Examples: null pointer exception, array index out of bounds exception, occurs due to programming errors. Explain Java lambda function expressions. Introduced in Java 8 to enable functional programming. Provides a concise way to write anonymous functions. Used with functional interfaces, that is runnable, comparator, etc. Example: A, B, A plus B. Next question. Purpose of the try catch block. Handles runtime exceptions to prevent program crashes. Try contains risky code and catch handles exceptions. Ensures graceful error handling. Example: try int x is equal to 10 divided by 0. Catch arithmetic exception E, system.out.println error. Next question. Difference between collection and collections. Collection. It is an interface representing data structures, that is list, set, etc. Collections, a utility class for collection operations, that is sorting, searching, etc. Next question. Use of the finalize method, called by garbage collector before an object is reclaimed. Used for cleanup operations, that is closing files, releasing resources. It's deprecated in Java 9 due to unpredictable behavior. Next question. Explain Java 8 optional. A container object for handling null values safely. Helps avoid null pointer exception. Methods, that is off nullable, is present, or else, map, etc. What is the Java collection framework? A set of classes and interfaces for managing groups of objects. Includes list, that is array list, set, let's say hash set, map, hash map, queue, priority queue, etc. Provides efficient data structures and algorithms for handling collections. Explain Java 8 completable future. A non-blocking way to handle asynchronous programming. Supports callbacks, then apply, then accept, and chaining multiple tasks. Uses the fork join pool for efficient execution. Next question. What is multithreading in Java? Allows parallel execution of multiple tasks, that is threads. Improves CPU utilization and performance. Created using thread class for runnable interface. Managed using executors, fork or join in completable future. Next question. Purpose of the strict FP keyword. Ensures consistent floating point calculations across platforms. Enforces IEEE 754 standard for precision. Used with classes and methods but not variables. Next question. Difference between sleep and wait. Sleep possesses thread but retains lock. Wait releases a lock and waits for notify. Next question. Difference between linked hash set and tree set. Linked hash set maintains insertion order, while tree set maintains sorted order, natural or custom comparator. Linked hash set uses a hash map with a linked list, whereas tree set is based on a red-black tree. Linked hash set has order 1 time complexity for add, remove, and contents, while tree set is order of log n due to tree balancing. Linked hash set allows null elements, but tree set does not allow null, throws null pointer exception. Linked hash set is best for maintaining insertion order with fast lookups, while tree set is ideal for sorting unique elements and range queries. Next question. What is synchronization in Java? Synchronization in Java is a mechanism that ensures thread safety by controlling access to shared resources in a multi-threaded environment. It prevents race conditions and ensures data consistency when multiple threads access a thread object. Java provides synchronization through the synchronized keyword, which can be applied at the method or block level to allow only one thread to execute a critical section at a time. Additionally, explicit locks, that is re-entrant lock, volatile variables, and atomic classes, that is atomic integer, concurrent hash map, offer alternative ways to handle concurrency efficiently. While synchronization ensures safe execution, excessive use can lead to performance overhead due to thread blocking and context switching. Okay, these are the top 50 intermediate core Java intro questions and answers. Next, we are going to cover top 50 advanced interview questions and answers. In this first question, how does the JVM handle method overloading and overriding internally? Method overloading is resolved at compile time, whereas the compiler determines the method signature based on argument types. Method overriding, on the other hand, is resolved at runtime using dynamic method dispatch, where the JVM decides which method to invoke based on the actual object type. Explain Java's non-blocking algorithms and how they differ from traditional blocking algorithms. Non-blocking algorithms allow multiple threads to operate on shared data without using locks, improving performance and avoiding issues like deadlocks. In contrast, traditional blocking algorithms use locks to synchronize access, potentially leading to contention and reduced concurrency. Next question. How can you create an immutable class in Java? To create an immutable class, declare the class as final, make all fields private and final, do not provide setters, ensure deep copies of mutable fields in constructors and getters, avoid exposing mutable references. Next question. Describe the contract of hash code and equals methods. If two objects are equal according to equals method, they must have the same hash code. However, two objects with the same hash code may not necessarily be equal. Properly overriding both the methods ensures correct behavior in hash-based collections like hashmap and hashset. Next question. What is type inference in generics? Inner workings of concurrent hashmap. Concurrent hashmap in Java is a thread-safe, high-performance alternative to hashmap. Optimized for concurrent access. How it works? Segmented locking, that is Java 7 and earlier. The map was divided into segments, reducing lock contention. Second, cache, compare and swap, and fine-grained locking, that is Java 8 plus. Instead of segments, it uses locks at bucket level and cache operations for updates. Bucket level synchronization. Write operations lock only the affected bucket, allowing parallel updates. No lock for reads. Most read operations, that is get, are lock free, ensuring high performance. Improved scalability. Reduces contention, making it efficient for multi-threaded environments. What are the key benefits? Faster than collections dot synchronized map due to reduced locking. Supports high concurrency scenarios like caching and real-time analytics. Atomic operations, put if absent, compute, etc. ensure thread safety. Next question. Explain the inner working of concurrent hash map. Inner workings of concurrent hash map, that is concurrent hash map in Java, is a thread safe high performance alternative to hash map, optimized for concurrent access. Okay. Basically, it was covered in the last, already we covered this. Next question. Describe the Java memory fence and its importance. Java memory fence and its importance. A memory fence or memory barrier in Java ensures proper ordering of memory operations in a multi-threaded environment, preventing reordering by the CPU or compiler. How it works? Prevents instruction recording, ensures operations happen in the expected sequence, ensures visibility across threads. Changes made by one thread become visible to others. Used in concurrency primitives found in volatile, synchronized, and lock implementations. What it's important? Why it's important? Prevents data races and inconsistencies in multi-threaded applications. Ensures correct execution order in concurrent programming. Optimizes performance while maintaining thread safety. Next question. Explain the concept of false sharing in Java. False sharing occurs when multiple threads modify variables that reside in the same CPU cache line, causing unnecessary cache invalidations and performance degradations. Next question. How do you handle out of memory in Java? To handle out of memory error, optimized memory usage and avoid memory leaks. Increase heap size using JVM options, that is -XMX. Use efficient data structures. Employ garbage collection tuning strategies. Implement graceful degradation mechanisms. Next question. Describe escape analysis in Java optimizations. Escape analysis is a compiled optimization technique that determines whether an object can be allocated on the stack instead of the heap, reducing memory allocation, overhead, and improving performance. Next question. Explain thread starvation and how to prevent it. Thread starvation occurs when low priority threads are indefinitely delayed due to high priority threads monopolizing CPU time. It can be prevented by using fair logs, that is reentrant log with fairness parameters, adjusting thread priorities carefully, ensuring resource allocation is balanced. How does class data sharing or CDS work in JVM? Class data sharing or CDS is a JVM optimization technique that reduces startup time and memory usage by preloading and sharing class metadata across JVM instances. How it works? CDS archive creation. During JVM execution, class metadata is stored in a shared archive file. Faster startup. On subsequent runs, JVM loads classes from the pre-compiled archive, avoiding costly parsing. Memory efficiency. Multiple JVM instances share the same metadata, reducing RAM usage. Next question. Explain Java's thread local allocation buffers, that is TLAB. Java's thread local allocation buffers, that is TLAB. Thread local allocation buffers is a JVM optimization that improves object allocation speed by providing each thread a private memory buffer in the young generation heap. How it works? Each thread gets a small pre-allocated space in the hidden space. First object allocation occurs within this space, avoiding synchronization. When TLAB is full, objects spill over to the shared heap, triggering garbage collector if needed. What are the benefits? Faster object allocation, that is no locking required, reducing contention. Improved GC performance, most objects remain in hidden, reducing old gen promotion. Better multi-threading efficiency, that is each thread allocates independently. Next question. How does the fork join framework work? The fork join framework introduced in Java 7 is designed for parallel execution of tasks using a divide and conquer approach. How it works? Task splitting fork. A task is split into smaller subtasks recursively. Parallel execution. The subtasks run in a fork join pool utilizing multiple CPU cores. Task joining join. The results of subtasks are combined once the computation is complete. Work stealing. Idle threads steal tasks from busy threads, improving efficiency. Next question. How does the fork or join framework work? The fork or join framework introduced in Java 7 is designed for parallel execution of tasks using a divide and conquer approach. I think just we discussed earlier. Then we can proceed to next question. What is the difference between pessimistic locking and optimistic locking? Pessimistic locking locks resources throughout the transaction, preventing concurrent modifications. Optimistic locking allows concurrent access but verifies data consistency before committing changes, reducing contention. Next question. Explain the inner workings of a Java agent. Java agents use the java.lang.instrument package to modify bytecode at runtime for load time, for profiling, monitoring, or altering application behavior dynamically. Describe the usages of Java Compiler API. Usages of Java Compiler API. The Java Compiler API, that is javax.tools.java compiler, allows programmatic compilation of Java code within applications. Key usages. Dynamic code compilation, that is compile Java code at runtime, that is scripting engines. Custom ideas and tools used in ideas for syntax checking and on the fly compilation. Code generation frameworks supports frameworks like annotation processors. Plugin systems enables plugins to compile and execute custom Java code. Testing and automation helps run dynamically generated test cases. Next question. What is the principle of locality and how does it apply to Java? The principle of locality states that programs tend to reuse the same set of memory locations frequently. Java optimizes cache utilization by keeping frequently accessed data close to the CPU. Next question. How does the G1 garbage collector work? G1 garbage collector divides the heap into regions and prioritizes collecting regions with the most garbage, improving performance and reducing pause times. Explain polymorphic inline caching, that is PIC. Polymorphic inline caching in Java. Polymorphic inline caching is a JIT optimization technique that speeds up method dispatch in dynamically typed and polymorphic code. How does it work? Catches multiple method targets instead of looking them off every time. Reduces virtual method call overhead by optimizing frequently called methods. Improves performance in polymorphic scenarios where multiple subclasses override a method. Impact on performance. Faster method dispatch than standard virtual calls. Reduces CPU cache misses by keeping method lookups efficient. Common in JVM JIT compilers like Hotspot. Next question. What is the difference between stamped lock and reentrant lock? Difference between stamped lock and reentrant lock. Locking mechanism or stamped lock provides optimistic and pessimistic locking, improving read performance. Reentrant lock. Traditional exclusive locking, allowing multiple reentrant acquisitions by the same thread. Read performance or stampede lock. Supports optimistic reads without blocking or making it faster. Reentrant lock. This does not support optimistic reads and always requires acquiring a lock. Write locking or stampede locking. Write locking or stampede locking provides an exclusive write lock, invalidating optimistic read stamps. Reentrant lock. Standard exclusive lock with thread reentrancy. Interruptibility or stampede lock. Write locks are not interruptible, making them less flexible in some cases. Reentrant lock supports interruptible locking, useful for responsiveness. Use case or stampede lock, best for high read, low write scenarios, that is caches, data structures. Reentrant lock, suitable for general purpose locking where fairness and reentrancy are needed. Next question. Explain the term busy spin in multi-threading. Busy spin in multi-threading. Busy spin is a technique where a thread continuously loops, that is spins, while waiting for a condition to be met. Instead of sleeping or blocking, it helps reduce context switching overhead but wastes CPU cycles. Example. When to while, not condition met. Busy, wait, spinning. When to use? Low latency systems, that is high frequency trading, where thread wake up delays are costly. Short wait times, where context switching overhead is higher than spinning cost. Drawbacks: high CPU usage can degrade system performance, inefficient for long waits, better to use log support.park or blocking mechanisms. Next question: how can you implement a custom class loader? Create a subclass of class loader and override methods like find class, load class, and define class to customize class loading behavior. Describe Java JIT compiler optimizations like loop unrolling and vectorization. The Java just-in-time compiler applies various optimizations to improve runtime performance. Loop unrolling reduces the overhead of loop control, that is incrementing indices, checking conditions by increasing the number of operations in the loop body and reducing the number of iterations. Vectorization converts scalar operations into vector operations, allowing multiple data elements to be processed simultaneously using SIMD, single instruction multiple data instructions, significantly improving performance on modern CPUs. Explain the use of the JStack tool. JStack is a Java utility that displays the stack traces of Java threads in a running JVM. It is useful for debugging, diagnosing deadlocks, and analyzing performance bottlenecks. Next question. Describe Java's Project Loom and its impact on concurrency. Java's Project Loom and its impact on concurrency. Project Loom, that is introduced in Java 21, enhances concurrency by introducing virtual threads, which are lightweight user mode threads managed by the JVM. Impact on concurrency. Massive scalability, supports millions of virtual threads versus limited operating system threads. Simplifies concurrency, replaces complex thread pool management with lightweight threading. Efficient resource utilization, uses fewer system resources, reducing context switching overhead. Better performance for I/O tasks, ideal for high throughput I/O bound applications like web servers. Easy migration, works seamlessly with existing Java threading APIs. Next question. What is a Java decompiler and how can it be used securely? Java decompiler and secure usage. A Java decompiler converts compiled class files back into readable Java source code, helping in debugging, reverse engineering, and learning from third-party libraries. Secure usage of Java decompilers. Avoid decompiling proprietary code. Respect copyright and licensing laws. Use for debugging and recovery. Retrieve lost source code from compiled classes. Analyze security risks. Identify vulnerabilities in compiled applications. Prevent reverse engineering. Use obfuscation tools, that is ProGuard, to protect code. Trusted decompilers. Use reliable tools like JD, GUI, CFR, or Flower to avoid malware risks. What are the challenges in implementing distributed garbage collection, that is DGC? DGC is complex because it must manage memory across multiple JVMs. Challenges include tracking object references across distributed systems, handling network latency and failures, avoiding memory leaks and orphaned objects, minimizing performance overhead. Next question. Describe the impact of JVM flags on performance tuning. Impact of JVM flags on performance tuning. JVM flags optimize memory, garbage collection, and execution speed, directly affecting application performance. Heap size management. My O-XMS size and -XMX size control initial and max heap size, preventing excessive garbage collection. Garbage collection optimization. O-X-XX colon plus use G1 GC -XS colon plus UAC Z GC colon tune GC for low latency or high throughput apps. JIT compilation. OXS tired compilation speeds up execution by optimizing method compilation. Thread and CPU usage. O-XX colon plus tired compilation speeds up execution by optimizing method compilation. Thread and CPU usage. Active O-XX colon active processor count equal to less than n greater than colon controls CPU usage for better multithreading. Logging and debugging. O-XX plus print colon plus print GC details monitors garbage collector activity, aiding performance tuning. Next question. What are Java modules and how do they enhance security and maintainability? Java modules introduced in Java 9. Java modules, that is module info.java, help organize code into self-contained reusable units, improving security, maintainability, and performance. How modules enhance security and maintainability. Encapsulation and restricted areas. Unlike traditional public classes, only explicitly exported packages are accessible, preventing unintended usage. Explicit dependencies require keywords to ensure a module only uses necessary dependencies, avoiding class path conflicts. Improved maintainability. Large applications can be split into small, independent modules, making it easier to manage and scale. Reduced attack surface. Since internal classes are not exposed by default, security vulnerabilities due to unintended access are minimized. Faster startup and performance. JVM loads only required modules, improving startup time and reducing memory usage. Next question. Explain the concept of Java 8 parallel stream. The parallel stream method in Java 8 allows parallel processing of collections using the fork join framework, improving performance on multi-core processors. Key features. Splits data into multiple subtasks and processes them in parallel. Uses fork join pool internally for task execution. Ideal for large datasets where parallelism improves efficiency. Order of execution is not guaranteed, unlike stream. When to use parallel stream? CPU intensive task, that is large computations, data processing. Processing large collections for better performance. Multi-core processors where parallel execution speeds up work. When to avoid? Small datasets, overhead may reduce performance. Dependent tasks, race conditions can occur. Modifying shared resources, risk of inconsistent state. Next question. What is a deadlock in Java? A deadlock occurs when two or more threads are indefinitely blocked, each waiting for a resource held by another. Example. Thread A locks resource 1 and waits for resource 2. Thread B locks resource 2 and waits for resource 1. Proper synchronization strategies such as lock ordering or timeouts help prevent deadlocks. What is the difference between executor and executor service? Difference between executor and executor service in Java. Definitions are executor. A simple interface for executing tasks asynchronously. Executor service, a more advanced interface that extends executor and provides additional control over thread execution. And functionality. Executor only has one method, execute runnable commands which runs a task asynchronously. Executor service supports more methods like submit, invoke all, shutdown, and await termination. Task handling. Executor just fires and forgets tasks without managing their completion. Executor service returns future objects, allowing task tracking and results retrieval. Shutdown control or executor does not provide shutdown control. Executor service provides method like shutdown and shutdown now to gracefully stop tasks. Next question. What is the difference between hash map and hash table? Synchronization. Hash map not synchronized, not thread safe. Hash table synchronized and thread safe. Hash map allows one null key and multiple null values. Hash table does not allow null keys or values. Hash map performance is faster, hash table slower due to synchronization. Next question. Explain Java 8 default methods in interfaces. Java 8 introduced default methods in interfaces using the default keyword, allowing interfaces to have concrete method implementations without breaking existing classes. Key features. Provides method implementation inside interfaces using default. Maintains backward compatibility without forcing all implementing classes to override. Supports multiple inheritance of behavior but avoids diamond problem with explicit method resolution. Next question. What is the difference between wait and notify? Purpose of wait causes the current thread to release the lock and enter a waiting state. Notify wakes up one waiting thread from the waiting state. Usage of wait called when a thread needs to wait for a condition. Notify called when a thread wants to signal a waiting thread to resume execution. Lock requirement. Both wait and notify must be called inside a synchronized block on the same object monitor. Thread behavior or wait. The thread releases the lock and goes to the waiting queue. Notify. The awakened thread must require the lock before proceeding. What is the difference between comparable and comparator? Comparable versus comparator in Java. Purpose. Comparable used for natural ordering of objects, that is sorting by ID. Comparator used for custom ordering, that is sorting by name, age, etc. Implementation of comparable. It implemented by the class itself. Implements comparable T. Next question. Comparator implemented as a separate class. Implements comparator T. Method used for comparable. Overrides compare to T object. Comparator overrides compare T object 1 T object 2. Usage of comparable used when a single sorting order is needed. Comparator used when multiple sorting criteria are required. What is the transient keyword in Java? Transient prevents a field from being serialized, meaning it will not be saved when an object is written to a file or transmitted over a network. What is the purpose of the instance of operator? Instance of checks if an object is an instance of a specific class or subclass. Example, if object instance of MyCycle do something. Next question. Explain the concept of log-free programming in Java. Log-free programming in Java ensures thread-safe, concurrent, without using traditional logs, that is synchronized reentrant log. Instead of relies on atomic operations and compare and swap to manage shared resources efficiently. How it works? Uses atomic classes. Java provides atomic integer, atomic long, atomic reference, etc. from java.util.concurrent.atomic. Relies on CAS, compare and swap. Instead of locking, CAS updates a value only if it has not changed, ensuring consistency. Avoids blocking and deadlocks. Threads keep retrying operations until they succeed, improving performance. Optimized by hardware. CS operations leverage CPU level instructions for fast, low overhead execution. Used in concurrent data structures, concurrent hash map, concurrent linked queue, and atomic stampede reference use log-free techniques. Next question. What is java.lang.refl ect.proxy used for? Proxy dynamically creates objects implementing interfaces at runtime. It is widely used in AOP, aspect-oriented programming, and frameworks like Spring. Next question. What are some advanced features of completable future in Java? Chaining asynchronous tasks, combining multiple async computations, exception handling, timeouts and default values, custom executor control. Next question. What is fork join pool and how is it different from a regular thread pool? Fork join pool introduced in Java 7 is a specialized thread pool designed for parallel processing of recursive tasks using the work stealing algorithm. It is part of the java.util.concurrent package. Fork join pool versus regular thread pool. Task type. Fork join pool designed for divide and conquer tasks, recursive task, recursive action. Regular thread pool executes independent, runnable and callable tasks. Work stealing. Fork join pool uses work stealing, that is idle threads take tasks from busy threads. Regular thread pool. No work stealing. Tasks are assigned to specific threads. Best use case. Fork join pool. Ideal for CPU intensive recursive parallel processing, that is sorting, tree traversal. Regular thread pool. Suitable for I/O tasks, web servers, and background tasks. Task splitting and execution. Fork join pool splits large tasks into subtasks. Fork and join. Regular thread pool, no built-in task splitting, executes tasks independently. Performance optimization. Fork join pool optimized for parallel execution using all available CPU cores. Regular thread pool works well for asynchronous task execution but lacks parallel optimization. Next question. How does the unsafe class work and what are its use cases? Unsafe class in Java, sun.misc.unsafe. The unsafe class provides low-level unsafe operations such as direct memory access, off-heap allocation, and atomic operations. It bypasses standard Java safety checks, making it powerful but dangerous. Key features: memory manipulation, allocation, allocate memory, free memory, put int, etc. Bypass constructor calls, allocate instance to create objects without calling a constructor. Cache, compare and swap operations for atomic variables used in java.util.concurrent. Thread operations, spark, unpark, park, unpark, get and set int, etc. Class loading manipulation. Define class, define anonymous class, then use cases. High performance library, that is NETTY, Cassandra, etc. Of heap memory storage, avoids garbage collector overhead. Atomic operations used in atomic integer concurrent hash map. Class and method hacking, modifying final fields, method handles. Next question. What is the phantom reference in Java? What is phantom reference in Java? Phantom reference from java.lang.ref is a special type of reference that allows post-mortem cleanup after an object is garbage collected. Unlike software soft reference and weak reference, a phantom reference is always null when accessed by a GET. Key features used for resource cleanup, that is deallocating native memory. Not automatically removed by a garbage collector. It is added to a reference queue instead. Ensures proper cleanup before memory is reclaimed. What is the role of java.lang.instrument? The java.lang.instrument package enables bytecode modification at runtime used in Java agents for profiling, monitoring, and aspect-oriented programming. Next question. How does the Java memory model handle out of order execution and memory visibility? Defines happens before relationships for correct memory visibility. Uses volatile and synchronize to enforce ordering. Prevents compiler and CPU optimizations that may break concurrency semantics. What is the difference between reentrant lock and synchronized? Synchronized is a built-in Java monitor lock while reentrant lock is part of java.util.concurrent.logs with more flexibility. Synchronized acquires and releases the lock automatically, whereas reentrant lock requires explicit lock and unlock. Synchronized does not support try locking, but reentrant lock allows try lock and try lock timeout time unit. Synchronized is unfair, no guaranteed thread order, whereas reentrant lock can be fair, new entrant lock true or unfair. Synchronized does not allow lock interruption, but reentrant lock supports locking interruptibility for better thread management. Synchronized uses wait and notify, while reentrant lock provides condition variables for finer control over waiting threads. Synchronized is simpler and easier to use, while reentrant lock is more powerful but requires careful handling to avoid deadlocks. Next question. What is the difference between weak reference and soft reference? Both weak reference and soft reference are part of Java's reference types in the java.lang.ref package, used to manage memory more efficiently by allowing objects to be garbage collected under specific conditions. Here is the key difference between them. Garbage collection timing. Weak reference, reclaimed immediately when no strong references exist. Soft reference, reclaimed only under memory pressure. Retention policy, weak reference, short-lived, discarded aggressively. Soft reference, longer-lived, retained until JVM needs memory. Use case, weak reference, used for lookup tables avoiding memory leaks, that is caches listeners. Soft reference, used for caching data that is expensive to reload, that is image caching object pools. Garbage collector behavior, weak reference, garbage collector clears weak references at the earliest opportunity. Soft reference, garbage collector clears soft references only when memory is low. Likelihood of being collected. Weak reference, very high, almost immediate collection. Soft reference, lower, kept until necessary to free memory. Next question. What is the difference between volatile, synchronized and atomic variables in Java? When would you use each one? These three are related to thread safety and concurrency control, but they work differently. Volatile keyword ensures visibility of changes across threads. When a variable is declared volatile, every thread reads its value directly from main memory, not from CPU cache. It does not ensure atomicity, that is, operations like count are not thread safe. Example, volatile boolean flag is equal to false, public void run, while not flag waiting for flag to become true. Here, changes to flag by one thread are visible to others immediately. Use case, when you just need to make sure threads see the latest value, that is a shutdown flag. Next, synchronized keyword ensures both visibility and atomicity. Only one thread can execute a synchronized block or method at a time for a given monitor or lock object. It prevents race conditions by locking a code block or method. Example, private int count is equal to 0. Public synchronized void increment count plus plus. Here, only one thread can run increment at a time, ensuring atomic operation. Use case when multiple threads modify shared data and operations must be atomic, like increment, update, etc. Atomic variables, that is atomic integer, belongs to the java.util.concurrent.atomic package. Provide lock-free thread safety using low-level CPU instructions, CS, compare and swap. Faster than using synchronized. Example, import java.util.concurrent.atomic integer. Atomic integer count is equal new atomic integer of 0. Public void increment count.increment and get use case when you need high performance thread safe atomic operations on single variables without blocking threads. That's it guys for this series. So these are the 100 intermediate and advanced core Java interview questions and answers. That's it guys for this series. Please like it, subscribe it, share with your friends.